Hello and welcome to the Terran Space Academy, where we help prepare you for a bright future in the space industry. Please don't forget to like and subscribe, and help us out on Patreon if you can. We appreciate you. We also have some nice gifts in the Academy store. The spacecraft entered the atmosphere of a hellish world at a velocity of about 10.5 kilometers per second. This wasn't the first alien visitor to the planet. 3 sister ships had died trying to land over the last 3 years. The first going silent at an altitude of 26 kilometers above the surface, while the second and third survived to about 12. Nothing had so far made it to the surface. All 3 of these probes had reported extreme heat before their death. This particular probe had a reinforced and heavily insulated titanium pressure vessel that had been cooled to minus 8 degrees Celsius before atmospheric entry, and was designed to survive up to 180 atmospheres of pressure and temperatures of up to 540 degrees Celsius. As the atmospheric density started to increase, sensors continually monitored the pressure and deployed a parachute when the pressure reached 0.7 bar. This was at an altitude of about 54 kilometers above the surface. The parachute was only 2.5 square meters in area total, but was constrained to just 1.8 square meters while still falling at 200 meters per second. The temperature continued to climb as the probe fell, and at 200 Celsius, the parachute would fully deploy. The parachute itself could withstand temperatures of up to 520 Celsius. It would take about an hour for the probe to come down to the surface, passing through clouds of sulfuric acid 54 kilometers up, while still going 200 meters per second. 33 kilometers above the surface, a permanent haze starts to block most of the sunlight. The atmosphere continues to thicken until it is no longer really a gas, but a supercritical fluid made mostly of carbon dioxide and nitrogen. Finally, the probe hits the ground at about 16.5 meters per second. Here the atmosphere is so dark that sunlight can barely penetrate to the ground. With a surface temperature of 475 Celsius and a pressure of 90 atmospheres. It is known that at one time this planet was much cooler, and may have had seas and harbored life. At that time, this planet would have been at an equilibrium point between the heat absorbed from its sun and the heat radiated back into space. This equilibrium point would have allowed liquid water to exist, creating the oceanic crucibles for life. But any trace of this life has been baked and melted from the surface. And this world is now so hot that molten metals run like rivers. This is what happens with the runaway greenhouse effect, where atmospheric gases such as carbon dioxide and methane trap heat, causing the ground to heat up, increasing volcanism, which releases much more carbon dioxide, causing the planet to heat more, until a new equilibrium is reached. Sadly, in this case, at a temperature and pressure that leaves no trace of any civilization that might have gone before. If it were not for a few satellites still in very high orbits, and the remnants of machines that had landed on its moon, there would be no trace left of whatever civilization had called the Earth its home. This scenario may sound too dire to be possible, but the Earth is much closer to becoming a mirror of Venus than you might know. Carbon dioxide levels have increased by 50% in the last 2 centuries. The Earth's oceans, having reached the limit of their ability to buffer the extra CO2, have increased their acidity by 30% in just the last few decades. That is damaging marine life, and, combined with human land use, has resulted in over 1 million species being threatened with extinction today. In fact, about 75% of all mammals will be extinct within about 3 centuries. Humanity may be among them. There are some who argue that the Earth is resilient, that the increased carbon dioxide is causing areas to green, and therefore balance will be found again. They are correct. The Earth is resilient. It survived the asteroid impact that wiped out the dinosaurs, and it will probably shrug this off also. The Earth was a frozen snowball for thousands of years, and a sweltering jungle planet for millions. There are many possible equilibrium points, but that doesn't mean we will be here to see it. Not all those equilibrium points allow humans to easily survive on the surface. The northern latitudes of Earth have tundra. Tundra is ground that stays frozen throughout the year. This tundra is now melting at an alarming rate. As the warming oceans redirect air currents, parts of the Earth that are normally cool with moderate summers are starting to swelter, while dry parts of the Earth, which would normally see little rainfall, are having monsoons. But one of the greatest climate threats to humanity right now is the frozen methane ice in the Arctic, called clathrates. If these clathrates completely melt, they will release 5,000 gigatons of methane into the atmosphere. Methane is a much more potent greenhouse gas than carbon dioxide, and a rapid increase in Earth's temperature would result. We are still a long way from this happening, but we are clearly headed in that direction, and other factors will start to predominate. Volcanism will increase as the Earth heats, and volcanoes produce lots of carbon dioxide. It was in fact volcanic activity that caused carbon dioxide spikes in the past on Earth, and what doomed Venus. If an overheating Earth were to cause the Yellowstone Plateau to become active again, it could devastate the entire world. And even if we avoid the extremes of Venus, humans may soon not be able to survive on much of their home planet without using advanced technology and a lot of energy. And that's where the problems start. Fossil fuels are largely responsible for the civilization we have today. Without these petrochemicals fueling our modern society, billions of people would have frozen and starved. And if we were to stop all fossil fuel use immediately, billions of people would freeze and starve. But now that the Earth has reached its saturation point, we must do something quickly. The question of whether or not we should geoengineer our planet has been answered. We have conducted a 500-year experiment in carbon dioxide production. And while the effects were clearly known to the oil industry by the 1960s, it is rapidly becoming apparent to everyone on Earth today. The Arctic is heating at a rate 3.8 times faster than the rest of the planet. This is due to shifting air and ocean currents. As these ice caps melt, the world's ocean levels rise. The world's most valuable real estate and infrastructure are on the ocean's coast. 600 million people live within 10 meters of sea level. These problems sound insurmountable, like humanity is doomed to go, if not the way of Venus, at least into a Mad Max world of scarcity. But this channel is not about giving up. It is about finding the solutions we need to all prosper together. What solutions can we find for the Academy to recommend? The oil and gas industry has been subsidized by taxpayer dollars for almost a century. We should start subsidizing green energy solutions at least an equal rate. What do I mean by green energy? Anything that does not pump carbon dioxide into the air or oceans. That means solar, wind, wave, geothermal, and carbon capture, as well as nuclear. Assuming we won't have fusion over the next few decades. Because, while there are companies that seem close, no one is there yet, and we can't count on what we don't yet have. Nuclear fission power is the greenest method of producing energy available to us today. When you factor in the carbon dioxide produced by the manufacturing of solar, the nuclear power industry was derailed in the 1960s, when the United States put the production of plutonium above safety, and the oil and gas industries funded anti-nuclear organizations. Light water reactors are inherently unsafe, and they produce tons of radioactive waste. But there are other forms of nuclear energy that are much better. We have discussed thorium reactors, which China is focusing on now, and there are reactor designs that actually use nuclear waste for fuel. These are called fast reactors, and they use high-speed neutrons for heat and to convert slowly decaying elements into fast decaying ones, increasing power output and getting rid of most of the nuclear waste. Bill Gates is funding a company called TerraPower that is working to make one of these designs a reality. There are also companies working to turn nuclear waste into small nuclear-powered batteries. One of these is the carbon-14 diamond batteries invented at the University of Bristol and now being developed by a company called Arcon Light. These batteries are ready to ship and can provide electrical power for up to 12 years. Nuclear power should be a part of the solution, but it is not the only answer. Nuclear power always has a non-zero risk of catastrophe. But if we design these properly, nuclear can be part of the future of human power production. And any waste that cannot be processed into a safe material can be sealed in a heavy reinforced cask and dropped here, right at the edge of a subduction zone. Billions of dollars were spent preparing a salt mine in Utah to hold nuclear waste for thousands of years, when all you need to do is cycle it through the Earth's interior. If this sounds too expensive, understand the United States spends $6 billion every year to maintain the radioactive waste created by the Manhattan Project back in the 1940s. Nuclear will be needed, especially small modular reactors, but solar will still be a part of the answer. Tax incentives and subsidies to put solar on homes, combined with battery packs, can not only reduce greenhouse gas emissions, but also make our infrastructure extremely resilient to natural or man-made disasters. A few years ago, an unusually cold winter in Texas resulted in gas line freezings and electrical cables snapping, cutting off power to 4.5 million residents. This 11-year-old boy froze to death in the United States of America in the 21st century, along with about 30 others. This was not the result of Texas using solar and wind, as some of the politicians tried to claim. All of the United States falls under federal guidelines for maintaining and protecting power systems from adverse events, except Texas. The power interests in Texas keep themselves off the national grid, so they can avoid updating their equipment and pocket more of the profits. Home battery systems would have protected these people. And I don't mean to imply that oil and gas is no longer needed. Any viable solution to humanity's current problems must include oil and gas for at least the next few decades. To keep this from making things worse, we need to stop using coal and start using more natural gas. Natural gas produces 50% less carbon dioxide than coal for the same power output. And we could do even better. Right now, cars and coal power plants only convert about 17 to 21% of the energy stored in hydrocarbons into usable energy. By developing efficient, affordable molten carbonate fuel cells, we would be able to reach an efficiency of 60%. This would allow us to have the same power levels as now, with about 1/3 the carbon dioxide emissions. Combining this technology with new thermovoltaic technology could increase its efficiency to 85 to 90%. Using molten carbonate fuel cells for ships and even airplanes might be a viable option. But thermovoltaics will change everything, especially in space. Just like solar panels turn visible light into electricity, thermovoltaic cells can turn infrared photons, heat, into electricity. Recent breakthroughs in thermovoltaics will allow us to have solid-state power generators with a 40% efficiency. This may not sound like a lot, but if you think about having a solar panel on top and a thermovoltaic panel under it, we could get about 40% power efficiency from solar and double it by another 40% with thermovoltaics. We can also double the efficiency of radioisotope thermoelectric generators, like those on the Curiosity rover on Mars today. And RTG devices powering cities with thermovoltaics would be as efficient as steam power generation is right now. These systems could also be buried under the city, in reinforced bunkers providing power through underground cables. Nuclear power can be used to make hydrogen, which is a very mass-efficient fuel source. But due to energy losses in the production process, it can be better just to use the electricity directly, except for airplanes. Airplanes are the one sector of transportation where high-value transport depends on low mass. Solar hydrogen, produced by using solar energy for water hydrolysis, would be a green way to produce hydrogen. It won't be as cheap as using hydrocarbons to make hydrogen, but it would be a much better solution to the carbon dioxide problem. There are some who will say that humans don't have the right to geoengineer, but that ship has sailed. Humans have altered the Earth's environment enough that if we all disappeared tomorrow, the world would still keep heating up, and the sea levels would rise. Exactly how high is hard to say, but even just 3 meters would be devastating to the world's economies, destroying trillions of dollars of infrastructure and real estate. Are there any steps we could take to drop the ocean's levels? We can look at a few suggestions. This is the Salton Sea. This inland sea was created back in 1905 when an irrigation canal from the Colorado River was dug to provide water to the Imperial Valley of California. Water from spring floods broke through a head gate and diverted part of the river's flow into a dry desert area that was 68 meters below sea level. This created a lake 24 by 56 kilometers. The inflow of water was finally stopped, and the lake has been shrinking ever since. And this gave some people an idea. What if we used an efficient, fast-boring machine to create a tunnel from the bottom of the lake out to the ocean and flooded the basin? How much would the Earth's ocean's levels drop? It turns out that we must remove about 361 cubic kilometers of water to drop the world's ocean levels by 1 millimeter. The oceans have risen about 120 millimeters since NASA started tracking it. It is expected to go up another 1/2 to 1.5 meters by 2100, depending on how much we curb emissions. This Salton Sea basin right now holds about 10 cubic kilometers of water, and it could only hold about 10 cubic kilometers more. So we would only affect a change in sea level of about 30 micrometers. But the Salton Sea basin is only the 10th deepest dry place on Earth. This site in Turkmenistan is called the Archanaya Depression, and it is 81 meters below sea level. The amount of water it could hold depends on the size of the basin, not just the depth below sea level, but even flooding this large basin would not be enough. It turns out that we would need to flood about 5 million square kilometers to a depth of at least 100 meters to drop the ocean levels by just 1.4 meters. Everything you see in gray would need to be flooded. I'm not convinced the current inhabitants will go along with that. It has been argued that we could erect a massive sunshade, parked permanently at the Earth-Sun Lagrange point 1. This shade would need to be about 2,000 kilometers wide, so about the same area as Greenland. This would block about 4% of solar flux, balanced carefully so as not to cause desertification from drying out. Strangely, warm air holds more water, and cooling the air can dry it out. While this is possible, the materials used would need to come from the moon. With self-replicating robots building and placing sheets of metal over decades, it would probably take a century to get this done. We could, of course, use this sunshade to generate power that could be beamed to Earth by microwave laser. These lasers can be 90% efficient, while regular lasers are only 20%. We could also seed the atmosphere with reflective particles, but this would need to be continuously replenished, and the side effects, such as ozone depletion, are unpredictable. All of these solutions are somewhat impractical, and to a degree, it is too late. The only thing for humanity to do at this point is to, as rapidly and completely as possible, without destroying our economies or causing the death of millions, wean ourselves almost completely off of carbon-producing technology, while at the same time increasing the energy we can produce. That's right, increasing it. The heat waves hitting Europe are not temporary. They will be permanent. We will need nuclear-powered desalination plants to pump fresh water up to the tops of mountain ranges, allowing it to flow down and irrigate our crops and cities through the existing infrastructure. Temperatures in the middle of the United States, in this area, will reach 51.6 Celsius during the summer by 2053. This temperature can be almost immediately fatal to anyone with a pre-existing medical condition, and even a healthy person cannot tolerate such heat for long. This area will contain about 100 million Americans. But most Americans have air conditioning, and we could learn to go out more in the evenings and at night and stay indoors. But most Europeans do not have air conditioning. As the climate changes and weather patterns shift, it will become necessary for survival that almost all homes have an environmental control system. These systems can pump heat out of or into a building, maintaining a comfortable internal temperature, if there is enough affordable power. And those without access to homes and resources would be left to die. This will be our future, whether we like it or not. There is no reasonable way to prevent the changes I've described from happening. But if we do not take immediate steps to reduce carbon emissions, these dire conditions will be seen as paradise compared to what will come. If we melt the methane clathrates at the bottom of the Arctic Ocean, this planet will not be habitable for humans for thousands, if not millions of years. You may have heard that the methane gun hypothesis, the argument that melting clathrates could doom humanity, has been debunked, but this is a mistake. The theory that ancient clathrate release events were responsible for past warming events is not supported by current data. But the fact that gigatons of melting clathrates would devastate the atmosphere is indisputable. Clathrates are right now deep under very cold water, and this eventuality is farther down the road. While permafrost, defined as rock or soil with water frozen for more than 2 years, which covers large sections of the Earth, is not. A recent study concluded that alpine permafrost is more sensitive to recent climate changes than Siberian. In fact, modeling shows that while only about 20% of Arctic permafrost will be lost soon, up to 65% of alpine permafrost will thaw, releasing up to 85 petagrams of methane. This is 85 billion metric tons. And methane traps heat 84 times more effectively than carbon dioxide. The methane will start breaking down, but before it does, the rising temperature on Earth will release even more, creating a runaway greenhouse effect, boiling the Earth's oceans, and making our planet almost indistinguishable from Venus. Everything humanity has created would be scoured from the surface, and the only trace of who we once were would exist in orbit, on the Moon or on Mars. Colonizing Mars is not a solution to this impending catastrophe. Developing the technology that allows us to stop emitting so much carbon is humanity's only long-term hope on Earth. But the technology we develop as we build colonies on the Moon, Mars, Mercury, and even Venus will bring us the technology we need to save the Earth, terraforming our own planet so that our descendants can survive. Otherwise, we will be a footnote in galactic history, an example of why there are not more civilizations visible in our galaxy. Something to think about. Thanks for listening, and stay safe. At Astra Pro Terra.